Welcome, brave minds, to the digital grid. You have a mission of utmost importance. TronBot must navigate the treacherous battle grid, a realm filled with formidable obstacles and mysterious images, the likes of which you've never seen. This is your first task. TronBot must conquer this formidable challenge, identifying the enigmatic images that lay in its path.
Hello world, I am TronBot, your mechanical companion in this digital odyssey. With circuits of steel and a heart of algorithms, I've been brought to life by an amazing team of experts to face this formidable task. Let me introduce you to them.
We are the Android wizards, who with a simple swipe and tap, possess the power to guide TronBot on this luminous adventure. Our first task involves setting up a Bluetooth connection socket, establishing a reliable channel to communicate with the Raspberry Pi. Within our interface, we design a user interface that facilitates easy reconnection with previously paired Bluetooth devices and can scan for nearby Bluetooth devices. To ensure robust connectivity, we've implemented an automatic reconnection mechanism that swiftly re-establishes the connection in case of disconnection. We've also integrated a connection status monitor to provide real-time visibility of the connection status between the Android device and external Bluetooth device.
On the system interface UI, we use a 20x20 grid map to simulate the arena. We also have a movement motion to be able to communicate with the Raspberry Pi and the STM. For obstacle setting, we use a drag and drop system to allow user to input obstacle anywhere within the arena bitmap. We also use a status monitor and obstacle tag identification to identify where the obstacles are and send them back to the Android device. Lastly, we also have the live update of the TronBot on the bitmap to display the TronBot latest location to the RPi. Together now we have an interface that grants user full control and monitoring capability. Now we need the help of the algorithm gurus to design the algorithm to guide the TronBot safely and efficiently through the grid.
Our mission is to design algorithms that will serve as TronBot's guiding light, making its journey both safe and successful. Our primary tool is the A-star pathfinding algorithm. This algorithm efficiently estimates the cost from the current node to the goal node, giving preference to nodes that are likely to lead to the shortest path. To expedite the exploration process, we maintain a priority queue. It allows us to expand nodes in the order of their estimated total cost, thus prioritizing nodes with the lowest estimated total cost. A-star swiftly identifies the shortest path while minimizing unnecessary exploration. What sets our A-star algorithm apart is its adoption of the Hamiltonian path. This ensures that our robot visits every obstacle exactly once, with no path across an obstacle being repeated.
To bring our algorithm to life, we have designed a simulation that showcases the path TronBot will follow to visit each obstacle. This simulation aids in visualizing the robot's journey in a controlled digital environment. Our algorithm establishes a connection with the Raspberry Pi through sockets, creating a communication channel. It receives obstacle coordinates from Android interface and transmits movement commands to the robot. This involves socket programming and data exchange protocols. Together, we have created a powerful algorithm that ensures TronBot's efficient navigation through the digital maze. Now, we need the STM sorcerer to bring life into TronBot.
We are the STM32 sorcerers entrusted with the task of configuring the hardware that powers TronBot. We have to ensure that TronBot sensors and motors are finely tuned to navigate the digital grid. Firstly, we calibrated the servo motor turning angles, ensuring precise control using the gyrometer and PID controller, and adjusted PWM values for smoother motor movements. We also set up connections for the ultrasonic and IR sensors, allowing TronBot to navigate around obstacles accurately. Next, we configured the STM32 board using STM Cube enabling physical connections in the code. We established a UART connection enabling communication between the RPi and the STM32 board.
We developed functions for the specific robot movements and turning, simplifying instructions from the Raspberry Pi. We also utilized UART for two-way communication, allowing the Raspberry Pi to send commands to TronBot and receive feedback for efficient command scheduling. These efforts have enhanced TronBot's control, navigation and communication, preparing it for its task. The sensors, motors and controllers are aligned, primed for action. TronBot's hardware is now a symphony of precision, ready to navigate the grid. It's time to pass the torch to the image sleuths, who will empower TronBot with the power of sight.
We are the image sleuths, and we've been hard at work to equip TronBot with the eyes to decipher this digital world. Here's what we've accomplished.
First, we trained and implemented YOLO V5S, a low-cost, high-performance object detection algorithm for real-time object classification in images. TronBot can now identify and acknowledge images in Flash.
We didn't just stop there. To ensure TronBot's image recognition is top-notch, we've collected a diverse dataset of all 31 images, further improving its model's performance. We even spiced it up with blur and brightness augmentations for a robust training set.
Communication is key, and we've mastered it. We utilized socket and parallel programming to effectively connect the brain of a robot, Raspberry Pi, with our key components: the image recognition system, the Android tablet, and the STM controller.
With many connections and different functionalities, our codebase had to be rock solid.
Through our collective efforts, TronBot can now recognize, navigate, and communicate effectively, ensuring its success in the digital realm.
Together, we've given TronBot the gift of sight, making it a true digital explorer. Our journey continues, and we are ready for the challenge that lies ahead.